It's my pleasure to present to you our Kaizen project, development of leak detection system on decoration machine. On our team, we have production coordinators, technicians, and engineers. And the presenters today will be Gerardo Espíndola, Ana Maldonado, and myself. And we are Trabajos. We represent Innova Polytech de Mexico Bottle Division. IPM is a manufacturing company focused on blow molding and decoration of PET bottles for the cosmetic market. We have four main processes. Blow molding. This PET is injected to the mold and then performed with high pressure air to form a bottle. Frost. In these processes, the bottle is painted and cured to get a glass frozen appearance. Hot stamping. Stamping bottle with a metallic fill using a hot mold. Silk screen. This is printing a bottle, applying it over a screen. IPM is located in Monterrey, Nuevo León, Mexico. We started operation since 1992, and we just celebrated 20 years anniversary in this year, with 365 people. Here we have our main customer line, Steve Lauder, Unique, and Victoria's Secret. The problem we have is holes in the base of the bottle, representing the 50% of our customer complaints of last year. We select Steve Lauder 200 milliliters based on the high volume of production and internal complaints. We have two ways to detect holes. As we can see, this video shows us the first method using visual inspection. But this way, holes are not detected 100%. Depends on factors like people get tired, small holes, bad illumination, operator criteria, and we detect models like defect, weight, and processing. The second method of detection is using an aromatic machine, as we can see on this video. It's 100% effective, but a person has to fill this machine with bottles having a no value added activity. And this equipment is really expensive. Here we have models like movement, overproduction, and model transportation. Now, we will present a capacity analysis.
Currently, we have 7 leak tester machines for an average of 40 deco lines installed on IPM. This means that we have covered only 17% by automatic detection, and the rest, 83%, goes to visual inspection, affected by all the problems that we just mentioned. The cost of each leak tester machine is around $32,000. So if we want to complete the rest of our deco lines, we will need to invest more than $1 million. After our analysis, we set our goal. That is the conversion of one visual inspection line to an automatic inspection line, reducing the equipment investment by 50%, but keeping the same quality in hole detection. Here we present our action plan. The central idea for this project came from the observation of our own decorating processes. In some of them, during decoration, the bottle is filled with air to give more support while it's being decorated. This is the same principle that the leak detection machine uses, air injection. So we decided to make the integration of the leak detection test within our own decorating processes, but at low cost. From Fish One, we got our root cause. That is, we are using a lot of lines with visual inspection. We cannot get molding as root cause because we didn't mold the 70% of the bottles we decorate per month. Also, the main problematic bottles are not molded on IPM. We use brainstorming and 7 mudas to get action to attack and solve this problem. And after that, we split our project into 3 steps. Step 1 is device type selection. We make trials into our machines, having restriction as cycle time and incoming air pressure. And first, we try with an air volume sensor and an air pressure sensor. These both devices didn't show any difference between a good bottle and a bottle with holes. After that, we try with an airflow sensor. This device shows a small difference between the reading between a defective bottle and a good bottle. So we could continue to the step 2. that is airtight system. As I have mentioned, these two bottles have readings was not enough to make our system functional. The difference was just 0.1 liters per minute, making our system unreliable. And this was caused by the leakage between the air filling nozzle and the bottle, as we can see on this animation. To solve this problem, we make our engineering of the air filling nozzle, change the material from stainless steel to Delrin. Delrin is an engineering plastic with the same hardness but more flexible. And also we change steel bearing and restrict the holes into the nozzle. As we can see here, in the animation, we eliminate the leakage between the bottle and the air filling nozzle and increase our difference. So this makes our system 10 times more reliable. The step 3 was the add-on. We installed a turret and a buzzer into our machines controlled by a small CPU to let the operator know when a bottle with hole is being decorated. We set the green light for a good bottle and the red light and the buzzer for a defective bottle. On this video, we can see our device installed into the self-screening machine and working online. Please notice when a bottle is being decorated, the green light starts on, showing that the bottle is a good bottle. And here we have our quality test. With this master bottle, if it's being decorated, the green light and the buzzer turns on. This master bottle has a size control hole. It's 0.15 millimeters and is used by the actual leak tester machine. Part of our standardization includes the implementation of documents as work instructions, quality controls, electric and electronic diagrams, and at this time we already have implemented this device in 5 more seal screening machines, and we are about to implement it in the hot stamping and the high-speed seal screening machine. Now we will present a summary for this project.
At this moment, we know we have a problem with our visual inspection and decorating lines. And the decorating machine is expensive. So we decided to develop a new device, so make the decoration and leak tester at the same time. This gave us additional improvements, like in people and usage. We had 6 people working in 32 square meters, and now we just have 5 people working in 24 square meters. If you want to see all the improvements in cost, we can see the next chart. We get 96% improvement in the equipment investment. We finished the conversion from the visual to the automatic inspection. We get 23% improvement in space and 70% improvement in quantity people, and we increased the productivity in 20%. So one line gave us a total of more than $7,000 for savings and more than $30,000 in cost avoid. Right now, in December, we just finished 5 lines more. That the total of the 6 lines gave us more than $43,000 in cost savings. And we just had a cost avoid that more than $184,000 for this project. But we have 27 lines more, so we have a potential cost savings that more than $194,000, and we have potential cost avoid that more than $828,000 if we continue with the rest of the decorated lines. If we want to make a comparative between the old system and the new IPM device, we can see this chart. If we buy 2 equipments by year, we need to make an investment that $64,000. But if we use the new IPM device, with just $35,000, we can complete all these 27 lines in just one year instead of 14 years with the old machine. So what is next? We have an automatic lines. That means use a high-speed spray machine. But these need more improvement in balance could make a test with the new device. So we took 1 line in this position, and we take it from the molding machine, go to paint frost machine, hot stamping machine, seal screen, leak detector, and packaging, and inspection. So we detect several improvements area to change, and we divide it in 3 steps. The first one is from the molding to the hot stamping. We can see 2 people working here. The first one is the person that moved the bottle. Now we have a pick and place arm to move the bottle from the molding to the paint frost. And the person was 100% checking the bottle from the injection. Now, instead of person to move the bottle from the frost to the hot stamping, now we have a pick and place arm to do this activity. So we have one less people. The next is from the hot stamping to the silk screen. Here we have 2 long conveyors in different height. Now we have 2 shorter conveyors in the same height, and we take off one pick and place arm to put the bottle to another conveyor. Here in the silk screen, instead of working in the first station, now we are working in the second station. If we have a problem with the silk screen process, we have less scrap in this movement. The third is from the silk screen to the end, that is inspection and packing. We have 3 people working here with 2 conveyors in different height. Now we take off one conveyor, put just one in the same height, and we put a pick and place arm instead of person to put the bottle in the correct way, that is the horizontal position. Now we can see the lead tester, and we'll put a table, so instead of 2 persons working here, now it's just 1 person making the inspection and packaging. So we can see the new layout. It's a small space, less space, and it's almost in automatic, and we just have 2 people instead of 4 people inside of the line. So we get improvements from 4 people using 46 square meters. We just have 2 people in 44 square meters. And the next step is work into the program machine to integrate the leak detector into the silk screen machine, so we can take off this expensive machine. For this improvement, we had 22% less in the usage space, 50% improvement in quantity and cost people, and we have 100% improvement in productivity because we are making the double with the half of the personnel. And we have 38% less in scrap. So for this line, we have a total of $19,000 in cost saving. And we have 4 lines more, so we have a potential savings more than $79,000. So all the project together, the manual lines with the new leak detector and the automatic lines, we have more than $63,000 in cost savings. And we just have more than $184,000 in cost avoid just with these 7 lines. So, but this is not just for Mexico, remember? We have 27 lines more, but we have in the world 2 more facilities with a similar process. So this could be done in IPG, Kentucky, United States. It can be done in SIXP in Shanghai, China too. So it's a great opportunity for all the NOAA to make a great cost avoid for the company. And now I will leave you with some pictures for all the team working on this great project. We hope you enjoy it as we enjoyed in this time. Thank you so much. Domo arigatou gozaimasu.
ですね、加瀬ひなりと言います。発表ありがとうございました。ですね、リークテスターの機械をですね、いろいろ検討されているコストを下げているところが分かりまして、非常に、設備投資を下げているということが分かってよかったと思うんですが、2点ほどですね、ご質問をさせていただきたいと思うんですけど、1点がですね、いろいろ改善をされて最後横転ということでラインを、作られているんですが、やはりそのリークテストの、設備をですね